Hi, and welcome to this presentation on Interaction to Next Paint. I'm Kevin Farrugia. I am a consultant on web performance and front-end. So what is INP, or Interaction to Next Paint? INP measures how quickly a page responds to a user interaction. That means once a user has clicked on an element or starts typing inside a text box, how long does it take for the screen to be updated or painted? As an example, over here we've got a text box. The page has a lot of JavaScript running in the background with every time you type. This is, for example, common when you've got a search with autocomplete. And what is happening is that when I type, not all the characters are immediately visible, but sometimes it takes some time until they are rendered or painted to the screen. So why do we have, or why are we looking at Interaction to Next Paint? So before Interaction to Next Paint, there was first input delay, which, or there still is first input delay, which measures the first interaction on a page. The problem, or one of the challenges with first input delay is, as we have mentioned, it only measures the first interaction on a page, and most of a user's time on the page is spent after that first interaction. Additionally, it only measures the delay in processing. So if I'm going to click on the text box and start typing, how long does it take to start processing my typing? Now, if submitting a key press event will cause a lot of JavaScript to run, blocking the main thread and therefore not painting the letter to the screen, that was not being included with first input delay, so it is only taking a portion of this measurement. First input delay has also seen huge improvements over the years, going up from 72% all the way up to 92% on mobile. This is data taken from the HTTP archive, and this means that we probably should start looking at another metric, because if everyone is getting a good score, then is it a good measurement? Is it still good for measuring? Because unless we have solved the problem and all websites are fast, which we know is not the case. So Interaction to Next Paint measures all user interactions on the page, and contrary to first input delay, it measures the time from the input until the frame is painted. So over here in this diagram, you could see the input delay, which is that first section down there, and that is what first input delay was measuring. How long does it take until it starts processing the event handler? Once the event handler, or whatever is required as part of the interaction, so an interaction could be made up of more than one event handler, so we've got point when you're clicking, for example, key down, key up, when you're pressing a button, or mouse down, mouse up, as an example, plus the click event. Sometimes there's a change event as well. So all that would be the processing time, and finally, once this event has finished being processed, it will render to the screen or layout, and then it will paint it to the screen. Interaction to Next Paint is taking the entirety of this time. So in the diagram where you've got input received, so the delay part, the processing, plus the presentation. Interaction to Next Paint, as we said, measures all interactions on the page. Now the scoring which you get is, or the score which you get, is the worst interaction on your page. If your page is highly interactive, for example, a word processor, where you've got loads of key down, key up events constantly, and the user spends a long time on the page, then it would take the 98th percentile to avoid outliers. So the worst score from all your interactions will be your INP score. So even if most of your interactions are good, but a chunk of them are going to be slow, then you're going to be getting a slow or a poor rating. To get a good rating, you need to have a score under 200 milliseconds, while on the other side, anything over 500 milliseconds is considered as poor. And these are the same thresholds on both desktop and mobile. So why do we need to look at interaction to next paint and responsiveness on the page? So this chart over here, this is taken from real user metrics from a client I'm working with. And as you can see, the more long tasks we've got, so the blue line is plotting the conversion rate, the yellow is plotting the long tasks. So as the amount of long tasks increase on the x-axis, the conversion rate is dropping on the y-axis, and we are going from approximately 40% all the way down to 11%. How do we optimize interaction to next paint? The biggest culprit for interaction to next paint is JavaScript. So most of the time, to have a high interaction to next paint means that your JavaScript or your main thread is very busy, and clicking or processing input events takes a lot of time, and you need to optimize your JavaScript. So this would be reducing work which is done on the main thread, reducing the size of your JavaScript bundles, go through your event handlers and make sure that any non-critical work is being delegated, for example, using the post task API, or if you are using React, check that you do not have unnecessary re-renderings. And in the case of single page apps, and most commonly with React, you've got to also be aware of hydration. So this would be when you've got the state created in the server side and you are hydrating it to continue using it in the client side. This usually blocks the main thread for a significant amount of time. How do we measure interaction to next paint? So the data is available on the CRUX dataset, the Chrome User Experience Report. And this makes it also available on Page Speed Insights, as you can see from the screenshot down here. If you want to measure it on your own page, for example, your website is not available on the CRUX dataset, then you could use the Web Vitals library, or you could create a performance observer which will monitor these events. And finally, if we take a look at how interaction to next paint looks in the real world and how much work is done especially when we compare it to the first input delay and the good scores we have seen on first input delay, we could see that across all origins in the CRUX dataset, so again, this data is taken from HTTP archive, across all origins on mobile, we've got 55% only which get a good INP. And as you can see from the table, some of the more popular frameworks also get quite a poor score, mostly because they are doing a lot of JavaScript and a lot of work on the main thread. Thank you for your time. I have included some links over here which I recommend reading if you want to continue looking at INP, and feel free to reach out to me on Twitter. Thank you very much.